talking about box plots. So a box plot, or a box and whisker plot, is a graph summarizing a set of data. Really, that's what all graphs are for. They just show a picture of a set of data. A box plot in particular shows the spread of data in 4 parts. It shows you how spread out the data is. The main purpose is to show that spread, or what we're going to call the distribution of numeric data at a glance. When I say distribution, that's really just a synonym for the word spread, how spread out something is, whether it's really clumped together or very spread out. It's especially helpful when you want to compare multiple groups. So there's going to be 4 equal parts that are created using these 5 different measurements. These are going to be the dividers that create those 4 sections. One that you're already familiar with is the middle value. That is the median. The minimum value, or the smallest number, is called the lower extreme, while the maximum value, or the biggest number, is called the upper extreme. Once we split this data in half, that's really what the median does. The median is going to split the data directly in half. What we're going to abbreviate as Q1 is called the lower quartile. And to find that, we're going to find the median of the lower half of the data. So you find the median, which splits the data in half. Then you find the median of the lower half. That's our lower quartile, or what we're going to abbreviate as Q1. We do the same thing with the upper half. We split it with the median. Then the upper half of the data gets split again with another median, creating Q3, or the upper quartile. All right, I'm going to show you exactly what that looks like in a second. Don't get confused yet. That's just describing those terms. The range, we already talked about this a little bit. That's the biggest minus the smallest. And then we have this new phrase, the interquartile range. That is Q3 minus Q1. So actually first I just want to talk about where that word is coming from, quartile. You can kind of see it in that word. The word quarter has the same base because this is splitting it into equal quarters. 1, 2, 3, 4 equal parts. Each of those is a quarter of the data. That's where that word is coming from. 25% of the data falls into each quartile. They're not going to look the same. You can tell this part of the box and this part of the box do not look the same. That's not what I'm saying, that they're going to be equal parts. I'm saying that they have the same number of numbers inside of that range. So let's say we had 20 numbers in this list. Let's say this was a list of 20 numbers. 5 would fall into here, 5 would fall into there, 5 into here, and 5 into there. It would be 4 equal parts, each having 25%. So each of these is 25% of our data. And that's created by each of the measurements we just talked about. I'm going to call it minimum here, or the lower extreme, the maximum, or the upper extreme, Q1, Q3, and then the median right in the middle. It splits it into those 4 equal parts. All right, so when we're making a box plot, first step has to be ordered from least to greatest. We need to see those numbers in order. And then we're just going to pick out each of those measurements, the lower extreme, upper extreme, the median. And then Q1 and Q3 take another step. But really, it is just visually looking at where is the middle of the lower half and where's the middle of the upper half. All right, so let's try that here. Below, there are 25 birth weights in ounces of all Labrador Retriever puppies born in Kingston Kennels in the last 6 months. So there's 25 birth weights. first thing I'm going to do, identify the lower extreme and the upper extreme. That's easy. These are already ordered from least to greatest, so 13 is the smallest, 20 is the biggest. Now I want to find my median. I'm just going to go one at a time, highlighting until we get down to the middle number. It's going to be one of these 17s. It's that one. It actually is important which one it is, because when we're finding the Q1 and the Q3, we're not going to include that number. That number does not get included when we're finding the upper and the lower quartile. So I found my median just by finding the middle number. I'm going to do that exact same process with the bottom half and with the top half separately. So I'm going to try to find the middle now. Same way I just did it. One number from each side till we get down to the middle. Actually, here we have two middle numbers, but either way, they're both 16. So 16 is my Q1. It is the middle, really it's in between those two 16s, but it's the middle of the bottom half of these numbers. Q3, we're going to do the same thing. Highlight from one, from either side until we get down to these two 18s. It's really in here, but that doesn't matter. Either way, it's going to be 18. So we have our 5 numbers. Our lower extreme is 13. Our upper extreme is 20. And then the box is formed by those 3 lines at 16, 17, and 18. We have our smallest, we have our biggest, you don't need to do this part. We have our middle, then we have the middle of the bottom half and the middle of the top half, creating our whiskers and our box. All right, median, mean, I guess I read that in the wrong order, mean, median, and outliers. Sometimes data value doesn't actually fit in with the rest of the data. These are called outliers. It stands out. It does not fit in with the rest of the data. These data values are important to consider because they can affect the measures of central tendency, the mean and the median, and they can skew what the graph looks like. If they change these in a way that makes it misleading, we don't want to include the outliers.